This section 6 should be a pretty straightforward section. There's just 3 formulas you kind of have to remember. This beginning part here is just an example of people using blogs and how quickly it got popular. And so if you notice here on the graph, you have November 2003, March 2004, and so these were the amounts of people that blogged, and you'll notice that it increased at an exponential rate. And so I think that's why they have this example. I'm not really gonna talk about this example, but it's just an introduction. And so if you scroll down a little bit, then you can kind of see the formula for a word problem for exponential growth. So if you look at this formula here, there are lots of variables, but each variable pretty much represents something. Okay, so y is what you're going to end up with in your final amount. A is like the initial amount. Okay, so if you have a savings account, how much did you put in there in the very beginning? R is your rate, usually an interest rate, and it has to be expressed as a decimal, and it's going to be a positive number. And then T is the time. And so this is for exponential growth. The only thing that's different about growth and decay is the plus sign. For a growth, it is 1 plus R. So let's read through this word problem together. It says the prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. Write an equation to represent the amount of the gift card in dollars after T days with no winners. Now, again, we have y is equal to a times 1 plus r is raised to the t power. The initial amount is $100. Okay, so I'm just going to kind of underline some things, and here's my a. And it says the rate increases at 2.5%. Now that's my R, but this needs to be expressed in decimal form. So this is actually 0.025. Okay, so that's what I'm going to be using. Now T I don't really know, that's fine. Okay, now my equation is going to be, let me just rewrite it here, y is equal to a times 1 plus my rate raised to the t power. And so I'm just going to plug in the variables that I know, and the variables I don't know, I'm just going to leave them as variables. I don't know my y. I don't know the final amount. I know my a is $100 because that's what I started with. And I have 1 plus my rate, I just said, is 0.025. And t just represents how many days go by. This is my equation. This is my final answer for part A. Let's move down to part B, and it says, how much will the gift card be worth if nobody wins after 10 days? Now this is your variable t for time. And so we're going to use this formula, and we're going to plug in t. So I have y equals the $100 that I started with, 1 plus 0.025 raised to the 10 days. And so you have to punch this into your calculator. If you're punching it in, do this first, parentheses first, then the exponent, and then multiply the 100. And let me see, take a moment on your calculator and do that and see what you get. After you punch that into your calculator, you should have gotten $128. So since nobody won in 10 days, and if there was a winner on the 10th day, this winner claimed $128. So that's exponential growth. Okay, we'll do a lot more examples of that. You do have to memorize this formula. Okay, let's turn to the next page, talk about compound interest. Compound interest is many times referred to like a savings account or money, okay, and it's usually an investment. All right, now the formula is very similar, but it has a little bit extra. Okay, so the problem, it says Maria's parents invested $14,000 at 6% per year, compounded monthly. How much money will there be in the account after 10 years? Now, there's a lot of stuff here, okay? First of all, when you see this word compounded, that's when you're going to use this formula, okay? This is the formula right here. Now, it's kind of the same thing. 14,000 is my initial amount. 6% is my rate, and again, it has to be in decimal form. And then 10 years is my time. Now, I'm going to tell you that for compound interest, your time will always be in years. Okay? Now, my formula looks very similar, right? There's an initial amount, there's still my 1 plus r over, now the only new thing that we have is this n raised to the n times t. Now the letter n is the same thing, okay? What n stands for is how many times is it compounded, okay? This tells you what my n is, okay? Let me give you a little chart of what the numbers will actually be. So compound interest is always for years, right? So if it's compounded annually, then it's 1. Semi-annually means twice in 1 year. Quarterly means 4 times in 1 year. Monthly means 12 times in 1 year. Daily means 365 times in 1 year. So if we look at this problem, it says it's compounded monthly. Therefore, my n is equal to 12. Which is why, if you look at what they filled in right here, you have $14,000, which is the initial amount, times 1 plus the rate, which is 0.06, over 12, because that's my monthly, and then all raised to the exponent 12 times the t, which is 10. And then you just have to put that in a calculator or do them individually and figure out what the final answer is. And so after you figure it out, you actually get an answer of $25,471.55. What that means is, even though you do nothing, because of this great interest, in 10 years, your original $14,000 turns into more than $25,000. Okay, so let's do this example. It says determine the amount of an investment if $300 is invested at a rate of 3.5% compounded monthly for 22 months. You know what? Let's change that to 22 years, just because, again, you need years. Take a minute to see if you can get the equation of using the compound interest equation. So I labeled all the variables that I was given, and all I'm going to do, I'm going to plug this into the compound interest formula. There's my formula. So I'm going to do the order of operations. I have to do parentheses first. Within my parentheses, I have to divide and then add, and then I do the exponent, and then I do my multiplying by 300. And my final answer, once I do that, $647.20. And so that's what we get for our compound interest when we put in $300, leave it for 22 years, and then we come back to it and we get $647.20. Okay, let's scroll down a little bit for the exponential decay, which is honestly the same thing as exponential growth that we did on the first page. So an exponential decay is where the original amount is actually decreasing. Okay? The formula is almost exactly the same, except that instead of an addition, you're subtracting the rate, okay? So if you look straight onto the real-world example here, actually what I want you to do for homework for tomorrow is I want you to fill this out and do the best you can with at least writing the equation, and then once you have the equation, estimate it. Okay, using the actual number of days. And so that's going to be your homework assignment. We'll finish this off tomorrow in class.